Implicit differentiation. Now, first of all, I want you to understand the word implicit. There are two words that we can talk about here, explicit and implicit. Have you ever heard those in English? Well, explicit is not bad words in math. That's not what it means. Implicit is when somebody implies something, when the speaker just implies it. What does it mean when a speaker will imply something? Yeah, they don't exactly come out and say it.
You have to extrapolate it.
Yeah, you have to infer from what they're saying. Explicit, you do not have to infer. By golly, they've said what they mean. Okay? By golly, there you go. In pre-calculus, we talked about two different types of equations that relate x and y, explicit and implicit. Explicit equations in x and y are such that y is isolated on one side of the equation and it equals an expression that is totally in terms of x. What does that mean? If I give you an equation like this, that's a plus, not a perpendicular symbol. That equation is written explicitly for y. I know exactly what y is. Y is x squared plus x minus 3. By golly, that's what it is. So that's an explicit function. An implicit function. That's an implicit function. I cannot solve that for y. I cannot make that thing say y equals. So what's y? I don't know. So that's an implicit function. When I look at an explicitly defined equation, I can explicitly tell if it represents a function or not. Now I want you to look at this. When I see that, I know that for every x there's only one y. How do I know that? Because what? What'd you say? I just didn't hear you. Because that's what it says. What if I put in x equal 3? What's the answer? What if x is 3? 4? Can it be anything else? No, it's 4. Every x has exactly one y, right? That's a function. Every x is matched with exactly one y. Now look at this. When x is 3, what is y? Plus or minus. Folks, that's not a function, because every x will have two y's, a positive one and a negative one. If you remember, that's called circle. You remember that? If you squared both sides, you'd get y squared equals 25 minus x squared. So x squared plus y squared equals 25. That's not a function. All right. Implicit equations are very different. Typically, they do not have y isolated on one side of the equation. Often there is a power on the y terms, and both x's and y's may appear throughout the equation. So take a look at that one. That's a circle. Now in geometry, I want to see if your answer is different from yesterday's class. Did you learn in geometry that that's the equation of a circle? Okay. You don't recall. All right. Yeah, I know for some of you it was a long time ago. Yeah. Calculus can even be applied to implicitly defined equations. In this lesson, we will see how to differentiate those equations that are implicitly defined. There are going to be more equations in the world that are implicitly defined than are explicitly defined. So we've got to know how to deal with them. All right. We will use an alternate notation for the derivative. This is what we've been used to, f prime of x. Now we're going to use this. You read that as, this notation right here is Leibniz's notation. This is Newton's notation. As calculus was developed by two different men, a blend of their notations has been accepted. We read this, even though it's a fraction, we read it as dy dx. And what does it mean? It means the derivative of y with respect to x. Ladies and gentlemen, that's exactly what this means. The derivative of y with respect to x. Now, here's what I want to show you. If I give you this, what's the derivative of x squared? Now let's look at the notation. This is the derivative with respect to x of x squared. Do you notice that those variables match? When they match, take the derivative, just like you know how to take the derivative. But what if this had been y squared? The variables don't match. So I have to use what's called implicit differentiation. And here's how it works. It's real simple. I take the derivative of this like I normally would, which is 2y. But because the variables don't match, I have to take the derivative of y with respect to x. How do I write that down? dy dx. So the only difference when you do implicit differentiation is if you are not using x, you're going to have to put this little notation in it. Let's try another one. I tell you to take the derivative with respect to x of x cubed minus 2y. Variables match, correct? I'm taking the derivative with respect to x. What's the derivative with respect to x of x cubed? 3x squared minus, that's it. The derivative of this with respect to x. I do it the way I normally would, but because my variables don't match, I have to write down dy dx. So how would we normally take the derivative of 2y? 2. But I've got to do times dy dx. Why? Because I am taking a derivative of a variable that's not the variable that I'm wanting.
I get that, but like, why do we have to take
Wait. Wait till related rates. Okay? Wait till related rates. Related rates starts on day 30. I do the derivative like I normally would, so the derivative of that would be 2. But because this variable is not the variable that I'm taking the derivative with respect to, I have to take the derivative of y with respect to x. So that's what this is. That's what this is. So look, the derivative with respect to x of 4y squared. What's the derivative of 4y squared? 8y. But I'm taking the derivative of some different variable. So I have to take the derivative of that variable with respect to x. Well, the derivative of y with respect to x is just dy dx. So the derivative of 4y squared would be 8y dy dx.
So f prime of x is like the same as d dx.
Yes.
But then y dx
is the same thing. Yeah, they're all the same thing. They're all different notations for the same thing. I promise. It just depends on what situation you are working with as to which form of the derivative you want to use. It will become more clear, I promise. Now, you've got a good amount of space down there. You're essentially going to divide this into two. We're going to take the derivative of this, and then we're going to take the derivative of this. Let's take the derivative of y equals square root of 25 minus x squared. You know how to do that. That's an explicitly written function in terms of y, because by golly, you know what y is. Now look, I want to take the derivative of that. Okay? So if that had said f of x equals, I would have written f prime of x. Correct? It doesn't say f of x. It says y. So you could write it as y prime. But the more common way to do it is say I'm taking the derivative of y with respect to this variable that's over here in the equation. So that's why I'm going to write dy dx. Now you guys know you would have to do, at least I pray to goodness you know, have to do a rewrite. What's that derivative? Clean it up. Now I'm going to put one little spin on this and it's going to make you mad, but hopefully you'll get over it. You okay here? What is the square root of 25 minus x squared? It's y, isn't it? You buy that? So this derivative is just the opposite of x over y. Now, just wait, you'll be all right. You'll be all right. If you were just doing this before today, you would have left your answer right here. But we're moving on, okay? Yeah, you got that? Now we're going to take the derivative of this. Now we're going to differentiate implicitly, which means we're taking the derivative with respect to x, okay? What's the derivative of 2x? Snap, I did it again. What's the derivative of x squared? What's the derivative of y squared with respect to x? 2y times dy dx equals, thank you. If somebody wrote 25, I was going to just like have a fit. Somebody will, on a test, somebody will do that. How do we solve for dy dx? Because what's the derivative of a constant? It's all right. Let's make this say dy dx equals. How are we going to do that? Subtract 2x and then? That's it. We're going to subtract 2x and divide by 2y. Oh, look at there. Negative x over y. Now, there's something I told yesterday's group, and I want to share it with you as well. Don't write anything down here. I just want to show you something. In those related rates problems that we're going to do, we're going to talk about what is the rate of change of the area of a circle with respect to time. How would we write that? The derivative of the area with respect to time. Well, that's dA dt. You might be asked, how is the volume of a spherical balloon changing with respect to time? So we'd say the derivative of the volume with respect to time, dV dt. I'm just throwing that out there to let you know kind of where we're going. Not today, but later. Too many letters. Okay. Aren't some of you wanting to go to study engineering? Yeah. Honey, you gonna? Okay. We're on the next page, right? This is where your ruler's going to come in. Write the equation of that circle.
Wait.
You guys know how to write the equation of a dadgum circle. First, you find the center.
It's like X minus
This is geometry. This is geometry. R is the radius. Oops. Ava? You remember that formula? From geometry? Yes, you're going to need to know this. Yes, ma'am.
Let's go.
What's the center? How'd you figure out that the center was 3, -2?
Eyeballed it just
It just looked right.
yes.
What's the radius?
20.
1, 2, 3, 4, 5. Write the equation of the circle. Come on. Write the equation of the circle.
Minus 3 squared plus y plus 2 squared equals 25.
You guys have like that.
Multiply it out. Multiply it out.
Really funny, too.
Multiply it out.
Yes. Yes, teacher.
Miss Smith, how do you not eat counseling? Go to counseling. That's what the counselors are actually for. They're here for the teachers.
Mm-hmm.
You know, when they're nice.
She's right. This is general form of an equation of a circle. Now, take the derivative. Now we are taking the derivative with respect to x. What's the derivative? Go. 2x minus 6 plus what would the derivative be if you just looked at it and said, oh, the derivative is 2y, but the variables don't match, so it's 2y dy dx.
Oh. No.
Because in all of this, it's going to be to x, because x and y are the variables that we have in our equations.
But it could be really
No, because no, just I'm not even going to go there with you, not it. What's this? What's the derivative right here? Plus 4 dy dx.
Wait, the 4 has to be 2.
Yes, because now solve it for dy dx. How are we going to do that? I see dy dx twice. How do I make this say dy dx equals?
Possible, yes, we can.
Wait a minute.
Yeah.
You think a derivative of 4y wouldn't just be 4?
It would be 4, but your variables don't match.
No, I You get full. Never mind.
Oh,
Dude,
I-
fit G's full. The Y was way too late.
And does any of this have anything to do with some of you making low grades on your test? Work your tail off, you hear me? I want you to be working so hard that you walk out of here with a headache.
I can't go to basketball.
I'll call Coach Stewart. We'll work it out. Hmm. Ha ha ha. No, he wouldn't. That's how I made dy dx appear once. Mm-hmm. That's algebra.
I like that. Yeah, that's what you meant.
Yeah.
Wait, why don't we pull up? Oh. Never mind.
Never mind.
So what's dy dx?
Not what about.
Dy dx is negative 2x plus 6 divided by 2y plus 4. Why?
Unfortunately.
We got.
I could divide a 2 out of every one of those terms.
I say it's good.
Well, you ain't grading the papers, dear,
Why
because I said so.
do we write two?
That was a safe stop.
Mhm. Mhm. Because if you were doing this on a multiple choice, this option would not be there.
But would be
Safe spot on free response. If I divided a 2 out of the numerator and divided a 2 out of the denominator, they'd cancel anyway. How many multiple choice are on the AP exam? Roughly 45-ish.
Is it calculator or no?
Both. Both.
So it's 45 minutes on that take.
Okay. Okay. Now, I want you to see something else, though. I want you to see what would have happened. Hey, guys, come on. What if we went right back here? Don't write this down because you've already used most of your space. What if I had taken the derivative from right here with respect to x? How would I take the derivative of this piece right here with respect to x? Yep, yeah, chain rule. 2 times x minus 3 to the times the derivative of the inside plus times to the first times the derivative of the inside. dy dx, well done, equals 0. The derivative of y plus 2 with respect to x is dy dx. 1 dy dx. Now, we're going to clean that up. We're going to solve that for dy dx, okay? So this would be 2x minus 6 plus 2y plus 4. Now, remember, that's what was multiplied by dy dx, correct? So what do I get? I'm going to do a couple steps in my head. I'd have to subtract that, correct? Negative 2x plus 6. Guess what? That's what you got before. If we divide out a 2, now, because I wanted you to see how it worked both ways. Listen, you guys think this is hard. Wait till you go to medical school. Wait till you go to engineering school, okay? You ain't seen hard. Now, I want you to take a look at this. Complete the table below, finding the value of dy dx at each of the indicated points. This is dy dx. Remember? Right. We want to find the derivative of this function at the point 0,2. Now here's what I want you to see. I don't like that I've got that circle. Do you notice here that in order to find the derivative, not only do I have to know x, I also have to know y? That's okay, it's no problem. I know them both, it's 0.02. What's your notation look like? Here's what you're going to write. dy dx evaluated at. That's this long bar. And you're going to put 0,2 at the bottom of that bar, kind of like a subscript. Equals. So that says dy dx evaluated at 0,2. Or we might say, to be a little lazy, dy dx at 0,2. Plug in 0 for x, plug in 2 for y, and go for it. That's it. Now, this is where your ruler comes in. I want you to go to the point 0,2 on your circle. Wait a minute. What's dy dx mean?
With respect to y.
The derivative, which aka of a tangent line. So we're going to go back up and we're going to find the point 0,2. And we're going to draw the tangent line through that point, but the slope is 3/4. So up 3, right 4, or down 3, left 4. There's your tangent line. Questions? Let's do the second one, 3,3. So we're going to write dy dx evaluated at 3,3. What do you get? You get 0 over 5? 0? So you're going to go to the point 3,3. And you're going to draw a tangent line that has a slope of 0. So what's that line look like? Yep, it's horizontal. We're not going to do all these. We don't have time. Go to, let's do this one. dy dx at 8, -2. Undefined. How do you have a line that has an undefined slope? A vertical line. You go to the point 8, -2. Makes sense, doesn't it? Absolutely. That's my tangent line.
Okay. But you got to cross out the 8 over 0. You just
Oh, yeah.
you just write that down. It's just
Slope is undefined. Slope is undefined. Yep. Yep. The bell's going to ring shortly. That's not. Please go to the next page. I would like for us to do. Let's do this one right here. Yeah, I want to do the second one because Nathan and Daisy won't be here, and I want them to see one with an E in it. We're going to find dy dx. Okay, go. 2 plus. Okay, let's remember. How do you take the derivative with respect to x of e to the x squared? It's this times the derivative of this. So, what's the derivative of that? That times the derivative of the exponent with respect to x. dy dx equals two x minus 2y dy dx. Get your terms with dy dx on one side of the equation, the terms without it on the other side, and that's how you're going to solve for your dy dx. You with me?